Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before or even considered taking up programming. Today we will look at the concept of parallel processing. So what is parallel computer processing? To quote from Wikipedia, parallel computing is a type of computation in which many calculations or processes are carried out simultaneously. Large problems can often be divided into smaller ones which can then be solved at the same time. So what does that actually mean? Let's give some real-world examples. If you are in the business of producing wood or lumber for building or manufacturing, you'll need a certain amount of it to make the business viable. Say you planted a single tree and waited until it was 15 feet across and 100 feet tall. While this approach would produce a lot of wood, it will take a very long time to grow. Alternatively, you could plant hundreds or thousands of trees and let them all grow at the same time. That is in parallel to produce the amount of wood you would need much faster. To give another example, say you and your neighbour need to dig drainage ditches in your gardens or backyards. So each of you employs one worker to start the work. Then you notice your neighbour's worker is getting through the task faster than yours. So you go out and you buy your worker a bigger shovel and some energy drinks to speed the work along. Happy that the work in your garden is going faster, you relax for a while. Then later notice that your neighbour's garden is being worked on even faster still. The neighbour has now employed 2 additional workers, and those workers are working in parallel with the first to storm through the task. So how do computers manage this? What trick do they employ to do more work? The programs or applications you run on your computer or even your phone are made up of code running on the processor and accessing memory. In the early days of computers, these processors could only run one such program at a time. Anything else needing run would basically wait in line for its turn to be processed. In early attempts at multitasking, where computers gave the illusion of doing 2 or more things at once, this was carried out by starting one task and doing some processing on it, then pausing it to work on another task for a while, and then coming back to the first task to continue working on it. Slicing up the time allocated to each task helped to take the advantage of any natural breaks in the information flow, like waiting for a user to think about what to type in next, by doing something else during that particular time period. However, with the advent of multiple processing cores, computers could have 2, 4, or even 8 processing cores, which could each independently work on different tasks by dedicating each program to a different processing core. This applies to phones just as much as laptops. Phones are, of course, computers in their own right. So how does all this work? All of this magic is down to the operating system, the collection of code that runs your laptop, desktop, tablet, or phone. It decides which processing core to give which tasks to, making the best use of the available processing resources. This explains how a computer can run lots of different programs at the same time, and every process that can get a processing slot is back in the multitasking approach of waiting in line for its turn. How can I, as a programmer, make use of this? If you're writing a program to take in data and perform some processing on it and generate an output, as the program will be running on a single processing core, the speed of execution is limited by how much time your program gets on that core. If we break up the processing of the data by breaking up the data into smaller parts and giving each part to a separate process, this is called a thread. Then each of those independent threads will be treated as a separate process by the operating system, and thereby collectively get more processing time on the computer. And the main program merely needs to wait for the threads to complete before reading the output from each to produce the finalized output. However, as you can guess, not all processing tasks lend themselves to parallel processing, and even those that do need to be big enough tasks to justify the overheads of running threads. If you're curious just how this can be set up in PowerBasic, I've put a link in the description below to the project page for threads, which will give you access to the 3 videos and code for these projects using threads. However, that's it for today. Thank you for watching.